Okay, today we're going to learn how to analyze graphs of quadratic functions, and we are going to fill in our foldable. These are the important points on a graph. We have two graphs here. We have graph number 1, which is f of x equals negative x squared minus 8x minus 12, and graph number 2, f of x equals x squared minus 8x plus 12. And notice I graphed them both on the same coordinate plane because I wanted us to be able to see both types of graphs. So the first important point on a quadratic function is the vertex. It is the turning point. It's where it goes from up to down or from down to up. And if you'll notice on graph number 1, the vertex is this point right here. And that is negative 4, 4. So that is our vertex. And if we look on graph number 2, the vertex is down here and it is 4, negative 4. Okay, so the vertex is an important point on a graph. It's either the top or the bottom of the graph. All right, another important point of the graph, another important part of the graph is the axis of symmetry. The axis of symmetry is the imaginary line that goes through the middle of the graph. It always goes through the vertex, and it is always a vertical line because we're talking about quadratic functions, and so the axis of symmetry would be a vertical line. It is shown on the graph to be a dashed line or a dotted line, and you can see which ones they are, both of them. On graph 1, the equation of that line is x equals negative 4, and an axis of symmetry must always be written as an equation of a vertical line, which is always going to be x equals. And the number that it's going to be equal to is always your x value in your vertex. On graph number 2, you can see that the axis of symmetry is a vertical line. Its equation is x equals 4. Okay, the next important part of a graph is the maximum and minimum. A graph either has a maximum or a minimum. A maximum is the highest value. So if you look on graph number 1, the highest value, in other words, how high does this graph go? We are looking only at the y's because the y's are high and low. So on graph number 1, you'll notice that it goes all the way up to 4. It's the y coordinate of your vertex. And so your maximum, your highest value on graph number 1 is 4. You don't write x equals 4. You don't write 4 comma some other number. You don't put it in parentheses. It's just 4. It's the highest value. And it is a maximum because this graph only goes up to 4. It does not have a minimum because this graph goes down forever. That's what those arrows mean. On graph number 2 does not have a maximum. It only has a minimum because it goes down to negative 4. That's the lowest value. That's what a minimum is. It's the lowest value. And the lowest value on graph number 2 is negative 4. It does not have a maximum because it goes up forever. That's what those arrows mean. Okay, the next important parts of a quadratic function are the x-intercepts, solutions, roots, and zeros. They are all the same points on the graph. They are really, really important points on this graph, and they are where those graphs cross the x-axis. Those points right there are the x-intercepts, they're the solutions, they're the roots, and the zeros. The only thing different is the way we write them. So if we look at graph number 1, and we're looking at x-intercepts right now, the x-intercepts are where that graph crosses the x-axis. Well, it crosses the x-axis at negative 6, 0, and at negative 2, 0. Those are the x-intercepts. It's where it crosses the x-axis. On graph number 2, the x-intercepts are 2, 0, and 6, 0. Those are important points. If we go over to zeros, that would be over here. Zeros are the same things as x-intercepts, and you list them the same way. You list them as ordered pairs. So on graph number 1, the zeros, what a zero means is where your x value is 0. Or I'm sorry, your y value is 0. And so it's an ordered pair where your y is 0. So on number 1, it would be negative 6, 0, and negative 2, 0. On graph number 2, your zeros are the same as x-intercepts. It's 2, 0, and 6, 0. Okay. You should have heard all 4 of these terms in Algebra 1, x-intercepts, zeros, solutions, and roots. All of them were discussed in Algebra 1. All right, solutions are, what does x equal? Usually, when you're trying to solve a quadratic equation, you set it equal to 0. So you want to know, when y is 0, what is x? That's the same as the x-intercept or the zeros. The only thing is that solutions, we're trying to find out what x equals. So we write x equals, and there might be 2 solutions, there might be 1 solution, and there might be no solution. So on graph number 1, your solutions are where it touches the x-axis. That would be at -6 and -2. You do not write ordered pairs for solutions. It's just what x equals when y is 0. On graph number 2, your solutions are x equals 2 and 6. Okay, roots are exactly the same thing as solutions. You write them the same way, they're just called roots. Roots and solutions are 2 different words for the same thing. So on graph number 1, our roots are -6 and -2. On graph number 2, our roots are 2 and 6. And that's all there is to it. Those are the important parts of the graph of a quadratic function. The vertex, the axis of symmetry, there's either a maximum or a minimum, and you'll have to tell which one and then tell what its value is. If it's a maximum, it's the highest value. If it's a minimum, it's the lowest value. X-intercepts and zeros are listed the same way. They are ordered pairs. Solutions and roots are listed the same way. It's x equals. And it's all 4 of those mean where it touches the x-axis. It's really, really easy. Okay, so like I said before, sometimes quadratic functions can have 2 solutions, 1 solution, or no solutions. If it only has 1 solution, it's only going to touch the x-axis in 1 spot. Here is an example of a graph that only has 1 solution. It might look like this. I want my solution to be right there. And I didn't do a great job of it, but the solution is where it touches the x-axis. And it only touches the x-axis at 4. So your solution would be x equals 4. Your root would also be x equals 4. There's only one of them. Your x-intercept would be the ordered pair 4, 0. And the 0 would be 4, 0. Remember, that's 4 different ways to say the same thing, and you write the answers or the values different ways. Okay, so that's if you have 1 solution. Sometimes you can have no solutions. So let's look at another one. And this one would have no solutions. This one right here has no solutions because you'll notice it doesn't ever touch the x-axis. So there's no solutions, no roots, no zeros, no x-intercepts. You just put none for all of that. And that's really all there is to it. So again, a quadratic function can have either 2 solutions, where it would look like this. It would cross in 2 places. It could have 1 solution. And when I say solutions, I also mean roots, zeros, and x-intercepts. It could have 1 solution, which would look like this. It would only touch in 1 spot. We're going to pretend it touches there. Or it could have no solutions, in which case it would never touch, and it would look like this. Something like that, where it never touches. Okay, and when we list the solutions, the roots, the zeros, the x-intercepts, if they're on points on the graph, it's really easy to find them, but sometimes they're in between points. And so I'm going to show you on the calculator how to find the solutions, roots, zeros, x-intercepts if they're in between 2 of the lines and you don't know exactly where they're at. So we're going to do that in a separate video that's coming up next.